Day 700 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. And today we have question number 3661, maximum walls destroyed by robots. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There's an endless straight line populated with some robots and walls. You are given integer arrays, robots, distance, and walls. Robots of I is the position of the ith robot. Distance of I is the maximum distance the ith robot's bullet can travel, and walls of J is the position of the jth wall. Every robot has one bullet that can either fire to the left or the right at most distance of I meters. A bullet destroys every wall in its path that lies within its range. Robots are fixed obstacles. If a bullet hits another robot before reaching a wall, it immediately stops and that robot cannot continue. Return the maximum number of unique walls that can be destroyed by the robots. Note, a wall and a robot may share the same position. The wall can be destroyed by the robot at that position. Robots are not destroyed by bullets. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have our input robots equals 4, an array of integers, which is one integer 4. Distance is also an array of integers, which is one integer 3. And walls is an array of integers with integers 1 and 10. This time the output is 1, meaning we can the number of unique walls that can be destroyed by the robots is 1. So there's only one wall that can be destroyed. It says robots of 0, which is 4. So this right here, index 0 is 4, fires left, distance of 3, covering indexes 1 through 4, and destroys walls of 0, which equals 1. So let's break this down one step further, right? So y'all can see what's going on. So let me just build this out so y'all can see the straight line path that we are on. So let's see, 5, 6, 7, 8, and 9, and then 10. Boom. So robot is right here at 4. So boom, let's just come right here to 4. And we could put an R for robot. So the robot is right here at position 4. The bullet can travel 3 distances or three indexes. So it can either go from here to here, boom, or it could go from here to here, boom. It can't go any further than that 3 distance. Now we have walls at 1 and 10. So let's come right here, and we could put a W right here because there's a wall right here. Let's clean this up because that's under 4. And then there's also a wall right here at 10. Boom. So as you can see, remember, it only can go 3 indexes. The bullet can only go up to 3 indexes. So that means if the robot shoots this way, it's not going to hit this wall because this wall is all the way down here. The bullet will only travel to right here. However, if the robot shoots this way, boom, it'll hit this wall right here. So it was able to destroy one wall, boom, or one unique wall. So that's why the output is 1. Boom. So just in case that didn't make sense, let's take a look at example 2. I'm going to leave the array, but we could reset where the robots and walls are. Boom. So let's get into an example 2. So in example 2, our input robots equals an array of integers 10 and 2. Distance is an array of integers 5 and 1. And walls is an array of integers 5, 2, and 7. So let's put our robots. We have a robot right here at 10. Hold on. We have a robot at 10. And we have a robot at 2. What the? And we have a robot at 2. Boom. Now, let's see. So we have, let me see where the walls are. We have walls at 5, 2, and 7. So we also have a wall right here. Ooh, so put a wall right here at 2. It's also a wall right here at 5. And there's a wall right here at 7. Boom. Let me clean this up. Boom. So it says this time the output is 3. And remember, before we go on, it says right here, a wall and a robot may share the same position. The wall can be destroyed by the robot at that position. So that's just a hint about what's going to happen at index 2. So, and it says in the explanation, robots 0, which equals 10, which is this robot 0, which means index 0 in robots, which equals 10, fires left with the distance of index 0, which is 5. So this index 0, sorry, y'all, this index 0 corresponds with this index 0, which had, so this robot at 10 can shoot up to a distance of 5, covering 5 and 10, which destroys walls. So hold on, y'all. Robot 0 equals 10, fires left with a distance of 5, covering 5 through 10. So boom, it's going to fire. Sorry, y'all. It's going to fire and cover these right here. Boom. Then, so that's going to destroy the wall at 5, which is the first wall, and the wall at 7, which is the last wall, right? Boom. So this robot right here can shoot up to a distance of 5. Boom. So it shoots this way up to 5. 1, 2, 3, 4, 5. In that shot, it's able to shoot through 2 walls. This wall, boom, is gone, and this wall, boom, is gone. So that was 2 walls gone. Now we have robots of 1, which equals to 2. This robot right here. Remember I said, remember this, because it's going to destroy this wall. Even though it only has a length of 1, so it can, or a distance of 1, so it can either go this way or it can either go this way. 1, luckily this robot is already on this wall, so covering covering walls 1 and 2, or index 1, or robots, or excuse me, yeah, positions 1 and 2, and destroys walls of 1, which is at 2, index 2, or position 2, I should say. Sorry. So that's how we got rid of that. So in total, we got rid of 3 walls, so the output is 3. Now, just in case that didn't make sense, let's take a look at example 2. I'm not going to go the whole distance because that goes all the way up to 100, and y'all should know how it works by now, but let's go through it anyway. It says in example 3, the input robots equals an array of integers. The input robots equals an array of integers 1 and 2, distance equals an array of integers 101, and walls equals an array of integers 10. The output is 0. It says in this example, only robots of 0 can reach the wall, but its shot to the right is blocked by robots of 1. Thus, the answer is 0. So, oh, this is the distance, not the wall. Sorry. So I can't bring this back. Let's bring this back. I thought that was the position went up to 100, but that's just the distance. So we have a robot at 1. Let me see. We have a robot at 1. Sorry, y'all. A robot at 1. And we have a robot at 2. Boom. Now, it says the distance for robot 1. So the distance, this corresponds to index 0. So distance for robot 1 can shoot up to 100 positions. Distance for robot 2 can only shoot 1 position. But the wall is at 10. So let me put a wall over here. Boom. So the wall is already all the way down here. This robot at 2 can only shoot 1 position. So the robot at 2 can only shoot to right here, right? Because this index 1 corresponds to this index 1. So this robot right here 2 can only shoot this far or this far. Can't shoot any further. Now this robot right here can shoot up to 100 positions left or right. So it could easily get this wall. However, it's going to shoot and boom, it's going to run into this robot. Once it runs into this robot, it says, where it says if a bullet hits a robot before reaching a wall, it immediately stops at that robot and cannot continue. So even though this robot can shoot up to a distance of 100 positions, it's going to be blocked by this robot every time it tries to shoot this wall. So in the end, it cannot reach that wall, so the output is 0. Boom, y'all. So I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we want to do is we're going to get the robots.count. So we're going to say let n equal robots.count. Boom. Now we need to pair each robot's position with its distance and sort by position. So we're going to declare a variable called a. We'll set that equal to, we're going to say zip, open up the parentheses, we're going to say robots, comma, distance. Come outside of that, we're going to say dot map, open up the brackets, open up some parentheses, we're going to say $0, comma, $1. Boom. Then we'll come outside of that, we'll say dot sorted, we'll open up the brackets and we'll say $0.0, comma, excuse me, not dot, comma, because we're sorting here, so we'll say it's less than $1.0. Boom. Then we're going to sort wall positions for the binary search. So we'll come underneath this and we'll say let walls equal walls dot sorted. Boom, put the parentheses. Now we're going to use a binary search for the first index where the value is greater than or equal to the target. So this is just going to be a small little function we're going to create right here. We have a few small little functions and a big function, but this is a small little function that we're going to create. So we're going to say, and it's going to be a binary search. So for the lower bound, so we're going to say func lower bound, open up the parentheses, underscore arr, colon, that's going to be an array of integers, so square bracket, int, square bracket. Come outside the square bracket, we're going to say comma, underscore, target, colon, int for integer, and it's going to return an integer. Boom, then we'll open up the brackets. Then we're going to say declare a variable called L, set that equal to 0, comma, R, set that equal to R dot count. Boom. So then we'll come underneath this and we'll say while L is less than R, we're going to open up the brackets and we've got to find the middle point. So we'll say let M equal, open up the parentheses, L plus R, come out, sorry, L plus R, and we're going to divide that, or excuse me, we're going to shift that, so greater than 1. Boom, so that's going to help with overflow. We'll come underneath this, we'll say if R square bracket M, come outside of that, equals, or excuse me, is less than target, we're going to open up the bracket and we're going to say L equals M plus 1. Then we'll come right here, we'll say else, open up the bracket, R equals M. Then we'll just come down here and we can say, sorry, y'all, come right here. Hold on, y'all. Let me clean this up. Let me make sure I got this cleaned up. Oh, yeah. Sorry, y'all. Yeah, we'll come down here. Hold on. Boom, we'll come down here outside of the while loop, but still inside this function, and we'll say return L. Boom. Now we got to come outside of this function, and we're going to create another function. This is going to be a binary function as well, where the first index of value is greater than target, not greater than or equal to target, and this is going to be for the upper bounds. So we're going to declare a variable called, or excuse me, a function. So we'll say func upper bound, open up the parentheses, underscore R, colon, square bracket, int, square bracket, come outside of that, comma, underscore, target, colon, square bracket, int, square bracket, come outside of that is going to, sorry y'all, this is just a regular integer. Boom, moving too fast, my bad. Then we're going to return an integer, and open up the brackets. And same thing, we are going to say declare a variable called L, set that equal to 0, comma R, set that equal to R, ARR dot count, L for left, R for right. Come underneath that, we'll say while L is less than R, we'll open up the brackets, and we're going to say let M equal, open up the parentheses, L plus R, come outside of that, is greater than 1, shift it, boom. Then we are going to say if ARR square bracket M is less than or equal to target, we're going to open up the brackets. We're going to say L equals M plus 1. Come right here. We're going to say else, open up the brackets. Same thing. We're going to say R equals M. Come underneath that, and we are going to say return L. Boom. Now we need to create another function that's going to count how many walls lie within the range. So come underneath this right here, declare another func called count. We're going to open up the brackets, say underscore L colon, that's going to be an integer, comma, underscore R colon, that's going to be an integer as well. Come outside the parentheses, it's going to return an integer. Boom. Now we're going to say if L is greater than R, open up the brackets and return 0. Boom. Come underneath this, and we are just going to say, hold on, y'all. Oh, hold on, y'all. Okay, yeah. Sorry, y'all. We're just going to say return upper bounds, open up the parentheses, walls, comma R, minus lower bounds, open up the parentheses, walls, comma L. Boom. Now that's that for that function. Boom. Now we're back into the main function. So we're going to declare a variable called avail. We'll set that equal to 0. And avail is going to be the max walls collected when the current segment is available. Then we're going to declare another variable called used. And we are going to set, and this is going to be the max walls collected when the current segment is already used. And we're going to initialize used with walls to the left or to of the first robot, and the range will be the position minus the distance or the position minus 1. So we are going to come right here. We're going to say equals count, open up the parentheses, A square bracket 0, come outside the square bracket dot 0, minus A square bracket 0, come outside the square bracket dot 1, comma A square bracket 0, come outside the square bracket dot 0, minus 1. Just like that. Now we need to add a dummy robot to simplify handling the last segment. So we'll come underneath this, and we'll put a dot append, open up the parentheses, open up some more parentheses. We're going to put int dot max, comma 0. Boom. Now we're going to iterate over each pair of consecutive robots. So we'll come underneath this, and we'll say for I and 0 dot dot less than n. We'll open up the brackets, and we need the current robot position and distance. So we'll say let open up the parentheses L dot D1 equal A square bracket I. Oh, excuse me, not D1. This should be DL. Boom. Then we're going to say, for the next robot, we're going to say let open up the parentheses R, comma DR. We're going to set that equal to A square bracket I plus 1. Boom. Then we need to define the reachable intervals between the robots. So we are going to come underneath this, right here, and we are going to say let L1 equal L plus 1. Boom, and we're going to say let R1 equal min, open up the parentheses, L plus DL, comma, L plus 1. Boom. Then we'll come underneath this to get the range where the next robot to the right one can reach. So we'll come underneath this, and we are going to say let L2 equal max, open up the parentheses, R minus DR, comma, L plus 1. Boom. Then we're going to come underneath this, and we're going to say let R2 equal R minus 1. Then we're going to count walls reachable by left robot only by coming underneath this. We're going to say let left equal count, open up the parentheses, L1, comma, R1. Come underneath this, and we're going to say let right equal count, open up the parentheses, L2, comma, R2. Boom. Then we're going to count walls reachable by both robots. So we'll come underneath this, and we'll say let both equal left plus right minus count, open up the parentheses, max, open up the parentheses, L1, comma, L2. Come outside of that, say comma, min, open up the parentheses, R1, comma, R2. Boom. Now, we're going to come underneath this, and we're going to say Navail is either going to extend previous available segments and take the left walls, or keep the previous used state. So we're going to say let Navail equal, open up the parentheses, max, open up, max, then open up the parentheses, avail plus left, comma, used. Then we're going to say used, and that will either use both sides, consume overlap smartly, or extend the used state with right walls. So we'll come underneath this, and we'll say let used equal max, open up the parentheses, avail, comma, plus, sorry y'all, avail plus both, comma, used plus right. Boom. Still not done yet though, y'all. We're getting there. Now we need to update our dynamic programming states by coming underneath this, and we are going to say avail equals Navail, and we are going to say used equals used. Boom. Now we need to add the walls that are exactly on robot positions. So we'll come underneath this right here, and we'll say let robot positions equals going to be a set, open up the parentheses, a dot map, open up some brackets, $0.0. Then we'll come underneath that, and we'll say 4x in robot positions. We'll open up the brackets, and we'll say used plus equals count, open up some more parentheses, x, comma, x. Boom. Then the final result will be the maximum walls collected. So we just have to come right here, and we can say return used, y'all. Boom. That should be all she wrote. I know it was a lot, but we made it through. Okay, cannot find lower bounds. So how do we spell this function? Okay, so this should, let's just add an S right here. Hold on. Is that what we have? Oh, maybe. Yeah, that should do the trick. Let's see. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Ooh, and we got the wrong answer. So when that happens, that means somewhere in this code, we probably got the math wrong. So give me a moment while I try to figure out where this math is not mathing at. Let's check the binary searches first. Let's check right here. I think I found it, y'all. I think it's right here. Boom. Let's see if that does it. Let's see if that does it, y'all. Oh, that wasn't it. Let's see if we run it. If that did. See what that did after we run it. So that wasn't it. Oh, hold on. It should be R -1. Let's see if that did it. Let's see. It's accepted. That's accepted. So now let's see. We might be on to something, y'all. We might have found it. And look at that, y'all. 175 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the top of the middle part. This is the middle part. This is the bottom of the middle part. And this is the bottom of the code, y'all. And with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.